Mimi naitwa Engineer Mpya na toka Kasuma Technologies. Sisi ni wawakilishi wa Autodesk Tanzania. Tunafanya Tanzania, tunafanya Rwanda, tunafanya Kenya, tunafanya Uganda, Sudan mpaka Ethiopia. Kazi yetu kubwa hasa ni kutawanya ujuzi wa kubuni miradi kwa maana ya Computer Aided Design Solutions. Naitwa CAD, Computer Aided Design. Sasa kilichotuleta huku kukutana na hawa waheshimiwa hapa, tunataka kwanza kuwajulisha kitu gani kinaendelea katika design industry, ili wao nao waweze kuwa katika standard za kimataifa ya vitu ambavyo tunaona vinafanyika kwingine duniani, na tuna uhakika kwamba hata hapa kwetu vinaweza vikafanyika kwa namna ambayo ni ya kwa viwango vya kimataifa. Ndio kitu ambacho kimetuleta hapa. Alafu kitu cha pili ni kwamba sasa hivi dunia ambayo ni kijiji, tunapata wataalam kutoka mahali tofauti tofauti ambao huenda wana ujanja mkubwa kuliko huu ambao wa kwetu hapa tunao. Kwa hiyo tunaamini kwamba kwa kuwajulisha vitu gani ambao vinatumika kwingine huko duniani, serikali itaokoa hela nyingi sana. Itaokoa hela nyingi kwa ajili ya matumizi mengine ya kimaendeleo.
Civil 3D to be able to produce your geometrical design details. So this is the normal, I know most of us are already familiar with this, but the process is very, very important in terms of how you're doing it. So how you're able to do your calculations, cut and fill volumes, and the overall details. The next part will now be drainage. A very important part is some issue we have, especially with when it rains. Most of our towns and cities tend to get flooded because you don't have good design approach. So this is what we call the catchment area. So as engineer, I just need to know the rainfall intensity. The catchment area will be calculated for me. So I need to define my coefficient of runoff. And then from there, the application now start telling me things like culvert. Where exactly should I put the culvert? What's the size of the culvert? We'll be able to carry that water coming from that side, as you can see. So then once I've done that, I'm able to now start customizing, doing things like the inlet, the outlet, and various structural components of my drainage structure. So you need to also confirm things like the rainfall return period, the duration and the frequency of that rainfall, so that you're able to accurately design and predict the size of your drainage structures, which will be able to drain that water from the road safely into the sea or wherever you want to drain it to, without causing flooding within our cities and towns. Okay, so that's again something that I know most engineers we suffer from not doing very well, because we don't have correct tools to be able to enable us do it. So this application called InfraWorks can be able to help you design correctly and accurately, and then take it into Civil 3D, where you'll be able to use it to do the detailed presentations and construction documentation that can now be used to do the actual implementation of the project. So you are not even limited there, you still have bridges as well. So these are the box culverts, the bridges, wherever they are available. You are able to also design them in 3D. So it means that once I've got the road, my work as the engineer in charge of bridges is just to say where will the bridge start and where will it end. And this is what I was saying, we don't have to do bridge separately and the road separately. So all of them will be done within one environment, so that there's proper coordination and collaboration among the project team members, and we're able to align everything into one, so that we're able to evaluate and check on the possibility of them coexisting together and avoiding misalignment and various miscommunication that might come during project execution. So this uses what we call parametric modeling or parametric design. The work of the engineer is just to model one. So once I've correctly modeled one, actually that's a pier or abutment. So I just model one correctly, then I'll be able to apply it to the rest, because the shape remains the same, is the size which will vary according to maybe the terrain on which we are doing that. So I just do one, and then I will apply it to the rest based on the customization and the design requirement and the geometrical design requirement for that road. So that's what we call parametric design. Then you can perform analysis. There's the structural analysis process. This allows for integration with the structural bridge design process, where you're able to generate the structural design report, quantifications, and various analytical requirement of the project, all in a similar manner as you do it traditionally, but now we are automating and aiming at being more efficient and effective in terms of what we are developing. Then once the design is complete, you can send it into Revit, which you will use for structural detailing and the production of construction documentations of the same. Okay, so it means that we do the bridge and integrate it with the road, but when it comes to detailing and construction documentation, we link it up with this application called Revit, which is specifically meant for structural detailing in